In FeatureCam 2012 R2, we've included a number of improvements to the simulation. The simulation engine is being made a lot faster by including multi-threading technology. So if you have a PC with multiple cores or multiple CPUs, you'll see a vast improvement in the speed of simulation. We've also added a number of new tools to the simulation. You can now rewind the simulation by a number of steps. You can also, using the machine simulation, indicate any collisions, seeing these with an arrow. And we've also included the ability to start the simulation at a particular point during the process to avoid having to watch the entire simulation all the way through. We're going to look at some of these examples on this part. So here I've got my slide core part, and I've got a number of toolpaths already pre-created. If I go into my centerline simulation, I'm just going to single step to a position. Let's say I want to be here, and I can use the Alt forward arrow keys to go forwards, and I can use the back arrow key to go backwards. This allows us to quickly analyze the toolpath and see where the tool has just been, stepping back through and reviewing the progress. This can also be done in the 3D simulation, so I can use the arrow keys again, Alt right arrow to go forward, Alt left arrow to go backwards. In this example, I'm going to get so far through the simulation. You can probably see the speed of the simulation. I can vary the speed depending on what I want to see during the process. If I increase the speed to its maximum and then look at my CPU usage, you can see here we're using multiple cores. So up to 100% CPU usage as it makes its way around the part. Once we've finished our simulation, you can see I've got to a stage where I've semi-finished the part, and I now want to go ahead and calculate my finishing toolpath. However, I don't want to have to simulate this again, so I can go ahead and actually save the simulation at this stage by going View, Simulation, Use Results as Starting Point. Now I can go ahead and calculate my finishing operation, and in this case I've gone for a steep and shallow finishing toolpath. Play the simulation. This time I'm going to drop the speed down. We get the calculation of my toolpath, and you can see the simulation starts from the stage that I was at before. And in this case it's lucky I did so, because I've got a gouge here, but it meant that I've only had to watch the simulation from my finishing toolpath. So let's correct that with a longer tool by going to my finishing operation. I'm going to select a longer 8mm tool in this case that I've already pre-created and replay my simulation. Note that again the simulation will start from where I saved it with the previous toolpath. So now my tool is clear of the part. I no longer have a gouge on the part. I can finish like so. The final thing is the collision detection. So in this case I've got my toolpath. If I turn all these operations, I'm going to clear the simulation. So I'm going to go View, Simulation, clear the starting point. We'll now default back to the stock. In the setup, if I edit the setup, I've deliberately placed a large offset position for my machine. So when I go to simulate this, in this case on a Hermele machine, using the single step on the machine simulation, and you can see here it's telling me that the spindle has collided with the enclosure of the machine. If we show all of the machine, we can see here we have a collision location, and this is indicated by a pink arrow. Hiding parts of the machine allows us to see exactly where the collision is.